how molecules pass across membranes. We can do an experiment using whisking tubing, which imitates what happens in the second half of the small intestine. It has tiny microscopic pores in it, which do not allow large molecules through, but do let small molecules cross into the blood. This diagram shows what can happen with small molecules. Here I have a water molecule, and here I have a glucose molecule. These green stripes are representing the whisking tubing. So there we are. As you know, all particles vibrate, and occasionally they knock into each other and bounce away. So these molecules here are all vibrating and moving around. Occasionally some of them can pass across a membrane through the pore that is there in the whisking tubing. So some water can go from right to left, and other water molecules from left to right, and so on. The other thing you should notice is that not only is the water small enough to do that, but the glucose can also pass through and move from one side to the other using this process called diffusion. What this means is that after a period of time, the glucose will have spread, and the water, evenly across both sides of the membrane. Here we have a slightly different setup. This time, instead of glucose, we have starch molecules. You'll notice that starch is made of lots of glucose molecules, all linked together. The links we call bonds. This makes the starch molecule bigger than the glucose. Because of this, whilst the water molecules can still pass from one side to the other of the whisking tubing, as shown here, the starch molecule, however, is too big to fit through. And it doesn't matter which way round we do, it can't get through. What this means is that however long you leave this, the starch molecules can't get through, and they have to stay on one side of the membrane. So if you apply what we have just learnt, you can then see what happens when we have a mixture of both glucose and of starch. As usual, the water can move both ways through the membrane and the whisking tubing, as can the glucose. So we end up with glucose on both sides of the whisking tubing. The starch, however, is still too large to fit through, so the starch again cannot pass and remains on one side of the tubing. So the question is, how do we prove this? How can we show, using scientific methods, that the glucose has moved from one side to the other and that the starch hasn't? For this you have to remember the tests for both glucose and starch. Testing for starch. Add iodine solution, and the solution then turns back from orange into black. Testing for glucose. You heat the sample using a water bath with blue Benedict solution, and if the glucose is present, the solution will turn gradually brick red. As you can see, the blue solution will gradually change to brick red through green and orange, depending on how much sugar there is there.